On the morning of October 29, 2025, a small, dim object approaching perihelion drew the attention of 3 telescopes simultaneously. The Pan-STARRS survey in Hawaii, the European Southern Observatories (VLT) in Chile, and the Lowell Observatory in Arizona. It was catalogued as 3I Atlas, the third confirmed interstellar visitor to our solar system. At 0713 UTC, its apparent magnitude was recorded at 14.9, faint, typical for a dust-coated nucleus. 6 hours later, the same object shone at magnitude 11.3, 5 times brighter. That kind of optical surge should have been catastrophic. For a comet, such a leap implies sublimation, a violent release of volatile gases as sunlight boils frozen compounds. Yet the spectra told a different story. Instruments looking for cyanogen, hydroxyl, or even simple CO2 emission found nothing. No coma, no gas halo, no increase in dust reflectance. Just pure, unmodulated light. The energy curve doesn't add up, said Dr. Adrian Petrov, lead spectroscopist at the Mauna Kea Observatory. The surface temperature barely rose, but luminosity spiked as though the entire body reconfigured its reflectance. That phrase, reconfigured its reflectance, entered the record that day. From the beginning, the numbers resisted every explanation. The comet's albedo, its ability to reflect sunlight, was measured at 0.27, nearly 7 times higher than the soot-black average of known comets. Its surface behaved not like porous carbon, but like a smooth metallic compound. It was as if it had been polished, remarked Dr. Elena Ruiz of the Instituto de Astrofísica de Andalucía, reviewing the early data. What made the observation more puzzling was its timing. 3I Atlas reached perihelion at a distance of 0.34 astronomical units, well within the region where solar radiation typically tears apart an interstellar body. Instead of disintegrating, it seemed to stabilize. The usual tale, those streaming filaments of vaporized ice, was thin and geometrically narrow, unlike the diffuse glow of an ordinary comet. The spectroscopic signature from the Gemini North Telescope confirmed the absence of water. Less than 4% of its composition fit the profile of typical volatiles. Instead, strong absorption features appeared around 850 and 950 nanometers, corresponding to nickel-iron bonding patterns, common in engineered alloys, rare in natural cometary cores. Still, most astronomers refuse to speculate. Data can deceive, detectors can glitch. But by 19:1 SI UTC, the brightening had been logged by over 40 observatories worldwide. Even amateur networks using backyard instruments recorded the same unfiltered surge. In ordinary language, a comet had glowed without burning. The Minor Planet Center released a brief, cautious bulletin that evening. Object 3I Atlas displays unusual photometric behavior inconsistent with expected volatile emission. Further analysis required. Nothing more. No theory, no speculation, just a single phrase, inconsistent with expectation. But within professional channels, unease spread quickly. By midnight, private correspondence between data teams in Hawaii and Chile already questioned whether the brightening was internal, something happening within the object itself, not on its surface. If true, it would mark the first time a celestial body had altered its luminous output without a measurable physical cause. By dawn on October 30th, 3 Atlas was still glowing steadily. No coma, no fragmentation, no cooling. The solar wind should have stripped it bare. Instead, it endured, silent and pristine, like a mirror reflecting something we weren't supposed to see. No one knew it yet, but this was only the beginning. In the days that followed, 3I Atlas became the most observed object in the solar system and the most confounding. Every major observatory on Earth, from the Subaru telescope in Hawaii to the Atacama Large Millimeter Submillimeter Array, ALMA in Chile, turned its optics toward the interstellar traveler. What they saw was beyond comprehension. Comets brighten when ice turns to gas, ejecting jets that both illuminate and alter their motion. But the Atlas readings showed no trace of this familiar dance. There were no emission lines for cyanogen, hydroxyl, or carbon monoxide, the unmistakable fingerprints of cometary activity. The infrared spectra, cross-referenced by the Infrared Telescope Facility (IRTF) at Mauna Kea, revealed a surface temperature of only 182 Kelvin, far below the threshold required for sublimation. In plain terms, it shouldn't have been shining at all. The paradox is simple, explained Dr. Leah Anderson from Caltech's Division of Planetary Science. To glow that bright, it should be disintegrating. To remain stable, it should be dim. Atlas is doing both, neither fading nor falling apart. It's conserving energy as though governed by a different thermodynamic system. The numbers were merciless. Based on luminosity alone, the comet should have lost nearly 13% of its total mass during the outburst, an enormous blow-off equivalent to billions of tons of material. Yet, sensitive instruments on SOHO and Stereo A detected no corresponding plume of dust or gas. The surrounding solar environment remained as clean as before the flare. Astrophysicists began running calculations through their models, only to find that the energy distribution didn't fit any known curve. A team at the European Space Agency's Near-Earth Objects division tried to explain the anomaly as a rotational resurfacing event. Perhaps the comet's crust had fractured, revealing a bright metallic core. But the reflectivity pattern, consistent across all latitudes, made that impossible. A fracture should have produced chaotic flickering. Instead, 3I Atlas glowed uniformly, like a slowly turning mirror. When data from NASA's NEOWISE mission arrived, the paradox deepened. The reflected sunlight wasn't random, it followed a pattern. Over a 12-hour rotation period, the light intensity varied with mathematical precision, peaks and troughs repeating to within 0.1% accuracy. Natural comets are erratic, they tumble. This one rotated as though locked on an axis deliberately aligned with the sun. It's the stability that bothers me, admitted Dr. Pierre Lavigne, an orbital dynamicist from ESA. Nature doesn't do precision. Chaos is the rule out there. This object behaves like it knows it's being watched. He wasn't alone in thinking it. By November 2nd, observatories in Japan and Canada reported a subtle, non-gravitational acceleration, a faint, measurable push unaccounted for by solar pressure alone. It appeared at the exact moment 3I Atlas reached maximum brightness, then vanished just as abruptly. The force was too directional to be random, yet too weak to originate from visible jets. The effect lasted precisely 5 hours, 38 minutes, corresponding almost perfectly to 1/4 of the comet's rotation period. It was as if something had fired a microscopic thruster, then shut it down. For decades, astronomers had catalogued thousands of comets, each obeying the same physical laws. They brightened as they neared the sun, spewing volatile gases that acted like natural propulsion. But none had ever displayed an acceleration so precise, so clean, so deliberate. The implications were staggering. If 3I Atlas had indeed altered its own trajectory using an internal mechanism, it could not be a simple icy remnant from another star system. It would have to be something engineered. No one dared write that word in official papers. Instead, they hid it behind euphemisms: asymmetrical mass ejection, localized volatile concentration, coherent photonic response. But behind closed doors, a different term circulated, first as a joke, then as a whisper, active object. Meanwhile, another problem emerged. Under normal conditions, an interstellar body's brightness curve declines rapidly after perihelion as it recedes from solar radiation. Yet, 3I Atlas defied the trend. For 3 consecutive nights, its luminosity remained steady. Amateur astronomers began to speculate about an internal light source. Theories ranged from trapped luminescent gases to unknown crystalline structures. But then came the detail that made even the skeptics pause. The light was polarized, not randomly scattered, but negatively polarized. That meant the reflected sunlight was oriented at a specific angle against what physics would predict. Negative polarization is exceedingly rare, observed only in controlled experiments with nano-engineered materials on Earth. The results were double-checked by the University of Helsinki's astropolarimetry group, which found the degree of polarization to be 6.7% at phase angle 20 degrees, a value never recorded in any known comet. "It's a mirror that cancels its own glare," said Dr. Timo Saarinen, the lead researcher. His report was uploaded to the arXiv preprint server on November 4th and taken down 12 hours later without explanation. When questioned by Science Insider, Saarinen replied simply, "The data were real. That's all I can say." By the end of the first week of November, the paradox was undeniable. An interstellar object had increased its brightness fivefold without losing mass, exhibited controlled acceleration, emitted no volatiles, maintained an internal rotation synchronized with the sun, and reflected light in a way no natural body could. Still, the official line remained conservative. NASA's Minor Planet Center released a single update. Further observation recommended. Cause of anomalous brightening undetermined. But among astronomers, private conversations had taken a darker turn. 3I. Atlas wasn't simply behaving strangely. It was breaking the rules on purpose. On November 6th, the situation escalated further. The Pan-STARRS telescope, which first discovered 3I Atlas, detected a faint secondary object less than 0.02 AU away, possibly a fragment, possibly something else. It followed a nearly parallel trajectory. At first, the team dismissed it as a stray reflection or digital artifact. But when a follow-up scan from the Gran Telescopio Canarias confirmed it, the truth began to settle in. There wasn't just one anomaly anymore. There were two, and both bore the same name, Atlas. At first, the discovery of the second object, C2025K1 Atlas, barely reached the public. To the untrained eye, one icy fragment more or less meant little. But within scientific circles, the news detonated like a quiet bomb. The probability that two separate comets, both discovered by the same asteroid terrestrial impact last alert system, ATLAS, would appear within months of each other and both defy standard models was astronomically low, less than 0.2%, according to Dr. Avi Loeb of Harvard University's Astronomy Department. C2025K1 was not interstellar, at least by initial classification. It originated from the distant Oort cloud, the icy boundary shell of our solar system. It was expected to follow a highly elliptical orbit and, like many of its kin, to disintegrate upon approaching the Sun. Yet as November unfolded and the object began its perilous descent into the inner solar system, telescopes across both hemispheres watched with growing disbelief. It didn't die. Instead, it changed. During its solar passage, C2025K1's brightness first dipped, then surged in a sharp golden flare. The ALMA Observatory in Chile, analyzing its spectral profile, detected something unprecedented: a total absence of carbon lines, normally the dominant signature in cometary matter. Where there should have been broad absorption bands of hydrocarbons, there were none. Instead, the reflected spectrum exhibited narrow, metallic features. Between 520 and 580 nanometers, the wavelengths associated with nickel sulfides and anodized alloys. When the European Southern Observatory published the preliminary dataset, it immediately drew global attention. A carbon-depleted comet was supposed to be impossible. If you strip a comet of carbon, you strip it of what makes it a comet, said Dr. Marisol Herrera of the University of Lisbon. It's like finding a whale made entirely of bone and no flesh. The golden coloration fascinated observers. Typically, comets display gray or bluish-white tails, signatures of ionized gas. But C2025K1's reflectance profile was unique. It produced a broadband reflectivity peak at 516 emission meters, identical to the spectral hue of brushed brass under solar illumination. To the naked eye through high-powered telescopes, it gleamed faintly gold, like a metallic ember drifting through space. And like its interstellar counterpart, it refused to obey physics. As it slingshotted around the Sun, passing at just 0.25 AU, it should have lost over 40% of its mass and disintegrated into a debris trail. Instead, the Solar and Heliospheric Observatory, SOHO, recorded a stable, cohesive nucleus. Even more astonishing, the object emerged brighter, smoother, and cooler than before its solar encounter. Its albedo reflectivity jumped to 0.33, higher than polished steel. The initial consensus was simple disbelief. "It's not surviving, it's evolving," said Dr. Jamal Singh of the Indian Institute of Astrophysics, whose team compared pre- and post-perihelion radar echoes. The surface seems to be reorganizing after each solar pass, as though responding to heat rather than succumbing to it. The discovery coincided with another uncomfortable fact. Both Atlas comets, interstellar and solar, displayed synchronized non-gravitational accelerations at perihelion, and both brightened by nearly the same factor. These accelerations were measured at 2.8 plus 0.3 x 10^6 mem_s2, consistent across two entirely different orbital regimes. "That's not random," Loeb remarked during a Harvard roundtable. "It's reproducibility, and in science, reproducibility implies design." He wasn't alone in that thought. By mid-November, an informal coalition of astronomers from Cambridge, Caltech, and the European Space Research and Technology Centre, ESTEC, had begun compiling a comparative dossier on both Atlas objects. The document, later leaked under the title Atlas Twin Event Report, outlined a series of coincidences too precise to ignore. Both discovered by the same automated Atlas system. Both brightened by factors of 4.8, 5.0 without visible gas release. Both exhibited negative light polarization. Both underwent non-gravitational acceleration synchronized with solar radiation pressure. Both orbits, when projected backward, intersected near the same ecliptic longitude within a margin of 0.6 dig, matching, by pure chance, the origin point of the 1977 WOW radio signal. When that last detail leaked, the story escaped the confines of science. The Guardian, Le Monde, and Scientific American all ran cautious headlines. "Twin comets defy physics. Strange parallel behavior prompts new questions." But for every article that appeared, another quietly vanished. Reporters who reached out to NASA's Planetary Defense Coordination Office were told that due to federal budgetary constraints under the ongoing government shutdown, public statements were suspended. For the first time, it wasn't the data that frightened researchers. It was the silence. Private Slack channels used by NASA and ESA teams began filling with rumors. Missing log files, altered timestamps, unexplained data loss from cloud archives. One engineer at the Goddard Space Flight Center, under anonymity, admitted that telemetry packets from SOHO's LASCO cameras went missing exactly during the C2025K1 brightening event, 30 minutes of blank frames. Coincidence, perhaps, but to those already shaken by the impossible twins, it was another thread in a growing pattern. On November 17th, a group of independent astronomers from Japan, South Korea, and Argentina triangulated the Golden Comet's light curve. They found a rhythmic fluctuation, a 12-hour cycle of brightening and dimming, identical to that of 3I Atlas. The peaks were offset by precisely 6 hours, as if one object responded to the other. To the public, they were two distant comets. To those tracking their data, they were in dialogue. When ESA's Jean-Pierre Lavigne was pressed by a BBC reporter about the possibility of artificial synchronization, his reply was cryptic. "There is a difference between improbable and orchestrated. We are somewhere in between." And so, the world's greatest telescopes watched 2 points of light, one interstellar, one native, defy entropy together, trading brilliance across millions of miles. In every scientific era, there comes a moment when curiosity turns to unease. For the Atlas events, that moment had arrived. By the third week of November 2025, astronomy had stopped being quiet science. The air in conference halls was charged, and email lists that usually debated calibration standards were now thick with accusations, leaks, and unverified claims. The twin Atlas comets, one interstellar, one native, had breached the boundary between curiosity and crisis. The first crack came from within NASA itself. A mid-level analyst at the Jet Propulsion Laboratory, posting anonymously to a closed astrophysics forum, revealed that raw tracking data for 3I Atlas from October 30th through November 4th had been marked classified. Normally, comet telemetry was public domain, automatically uploaded to the Minor Planet Center database. Not this time. The file directory existed, but the data were locked behind a Defense Department credential wall. When reporters asked NASA's Public Affairs Office for clarification, the response was a vague statement about temporary data integrity review during the government shutdown. But everyone knew what that meant. JPL engineers had been ordered to hand over full telemetry to the All-Domain Anomaly Resolution Office, ARO, a Pentagon office usually responsible for investigating unidentified aerial phenomena, not comets. Officially, the matter was outside their jurisdiction. Unofficially, they were now the only ones with access. Meanwhile, the European Space Agency, ESA, began facing its own storm. On November 19th, the organization quietly suspended public access to the Gaia Data Release Portal, citing server maintenance. Within hours, leaked internal memos reached Der Spiegel, revealing a different reason. ESA's Science Directorate had issued an internal directive forbidding further publication of photometric or spectroscopic data relating to either Atlas object. The memo used one phrase that set the scientific world ablaze: sensitive findings under interagency evaluation. When pressed during a press briefing, ESA Director Josef Aschbacher refused to elaborate. "We are verifying our data with partner agencies," he said. Speculation at this stage would be irresponsible. But speculation was all anyone had left. By then, every major observatory on Earth had confirmed the same pattern. The two Atlas objects weren't simply similar, they were coordinated. Both rotated every 12.04 hours, both brightened and dimmed in complementary rhythm, and when plotted against time, the peaks in their brightness formed a waveform, one rising exactly as the other fell. The data spread like wildfire across encrypted astronomer channels. The working theory was that the comets were somehow communicating, not through radio waves, but through controlled modulation of reflected sunlight. "This is either the universe's greatest coincidence," wrote Dr. Lina Moretti, an optical physicist at the University of Bologna, "or we are witnessing deliberate photonic signaling across astronomical distances." Her post was deleted within hours. The New York Times, which obtained a cache of deleted ESA emails, ran a Sunday feature headlined, "Is NASA Sitting on a Cosmic Secret?" The piece quoted unnamed officials claiming the U.S. Department of Defense had requested silence from all government-funded space institutions. Within 12 hours, the article vanished from the paper's digital archive. A correction notice cited unverified sourcing. At the same time, amateur astronomers began noticing something even stranger. 3I Atlas's orbit appeared to have shifted slightly, enough to alter its predicted position by nearly 0.01 AU, a deviation that no known gravitational interaction could explain. When compared to old ephemerides, the data suggested that both atlas objects had subtly adjusted their paths to maintain line-of-sight alignment for the first week of December. For the first time, the word maneuver appeared in professional correspondence. When the International Astronomical Union IAU tried to convene an emergency meeting, the vote to classify the behavior as non-natural fell short by a single ballot. The implication was too explosive, said Dr. Miriam Coe, one of the attendees. Once you call it non-natural, you're no longer studying a comet, you're studying intent. As pressure mounted, political actors entered the fray. On November 24th, U.S. Congresswoman Anna Paulina Luna sent a formal letter to NASA Administrator Bill Nelson demanding immediate declassification of all records pertaining to 3I Atlas and C2025K1 Atlas. The document was published on her official website, but the attached PDF, containing the list of data requests, disappeared within minutes. By the next morning, the phrase Atlas cover-up was trending globally. Inside observatories, scientists faced a different problem: self-censorship. Researchers were quietly warned to avoid speculative language in their papers. Words like artificial, controlled, and engineered were flagged for automatic removal by journal editors. One internal email from the Astrophysical Journal editorial board explicitly read, "We will not accept manuscripts implying agency or intelligent control behind celestial phenomena." And yet, the evidence kept piling up. Radar imaging from Goldstone Observatory indicated that the nucleus of 3I Atlas wasn't spherical or elongated like typical comets. It was faceted, composed of smooth, angular planes that reflected radar pulses in coherent bursts, a pattern resembling geometric scattering. At a closed-door meeting of the Royal Astronomical Society in London, Professor Robert Kwan presented an off-the-record summary of the latest findings. The final slide contained only one sentence: "If it's not an error, it's architecture." The room was silent. Even those who still clung to natural explanations began to admit that the coincidence of two synchronized, metal-bright, self-accelerating objects couldn't be easily dismissed. But without open data, there could be no consensus, only rumor and fear. And as the world argued, both comets kept shining, locked in their distant dance, flickering with impossible precision. Each pulse, each oscillation felt almost deliberate. As if somewhere in the dark, something was still deciding how much to let us see. On December 1st, 2025, a confidential data packet from the Deep Space Network leaked onto a private astronomy forum. It contained raw telemetry logs, timestamps, velocity readouts, Doppler shift corrections for both 3I Atlas and C2025K1 Atlas. The figures, once decrypted, revealed something extraordinary. Both bodies were accelerating. Not erratically, not due to solar radiation pressure or residual outgassing, but with a degree of stability no comet had ever demonstrated. The acceleration was identical in magnitude, 3.0 plus 0.2 x 10^6 ms2, and more disturbingly synchronized across objects separated by millions of kilometers, their thrust vectors aligned toward the same heliocentric bearing as if responding to a shared command. For days, scientists wrestled with the implications. The acceleration had a waveform signature, rising and falling every 12 hours with mathematical precision. This matched the brightness oscillations long recorded by observatories around the world. When the two data sets, optical and kinetic, were overlaid, they produced a nearly perfect mirror image. In other words, when one object brightened, both accelerated. When one dimmed, both slowed. Correlation at that scale isn't coincidence, said Dr. Miriam Coe of the Royal Astronomical Society. You can't synchronize across astronomical distances without some form of control, either internal regulation or external input. It's not random physics, it's choreography. The word hung over every discussion that week: choreography. At first, many dismissed the leak as fabrication, but within days, the European Southern Observatory, ESO, confirmed the same pattern through independent measurements. The Atacama Large Millimeter Submillimeter Array (ALMA) monitoring in the submillimeter range recorded consistent spectral drift corresponding to velocity modulation, gentle, rhythmic bursts of momentum invisible to ordinary optical instruments. This is not sublimation, insisted Dr. Hiro Tanaka, senior astrophysicist at Japan's NAOJ. We are watching an active propulsion mechanism of unknown type, possibly photonic, possibly something we can't yet define. It is maintaining both orbit and distance with machine-level precision. Machine-level precision. Those three words appeared in a classified memo later circulated through ESA channels under the header Restricted. Non-gravitational response events. Within days, all references to the leak disappeared from scientific archives. But once data escapes onto the internet, it's never gone for good. Copies circulated on encrypted drives, dissected line by independent analysts, programmers, and amateur orbital dynamicists. Their conclusion was the same. 3I Atlas was maneuvering. One analyst, writing under the alias Cosmo Clairvoyant, demonstrated through orbital simulation that the object's path curved ever so slightly at regular intervals, countering natural drift. It's station-keeping, he wrote. Something's keeping it on course, as if maintaining a designated corridor relative to the ecliptic. At roughly the same time, a team at the University of Helsinki's Polarimetric Laboratory discovered a subtle but crucial detail. The pattern of polarized light from both comets shifted at the same moment each acceleration phase began. Polarization angles rotated by exactly 60 degrees, returning to baseline when acceleration ceased. That level of synchronization across independent celestial bodies defied every model of chaotic physics. When asked by Science Nordic what could cause such behavior, lead researcher Dr. Timo Saarinen hesitated before answering. Either we are misreading every instrument on Earth, or these objects are aware of solar pressure in a way we cannot explain. Aware, a dangerous word. It crossed a boundary the scientific community had fought to avoid. Meanwhile, NASA's Planetary Defense Coordination Office remained silent. Journalists pressed for comment, but the agency's press page hadn't been updated since October. Internal sources claimed that certain divisions had been ordered to cease communication with the public until technical verification was complete. The phrase quickly became a euphemism for containment. Outside the official channels, speculation bloomed. Some physicists proposed exotic material science theories, superconductive lattices, radiation-reactive alloys, or photonic crystals capable of redirecting solar momentum. Others whispered darker hypotheses: communication devices, autonomous probes, sentinels. The truth was simpler and stranger. If the data were correct, the objects were learning. Each subsequent acceleration phase showed slight refinements, reduced variance, smoother transitions, faster stabilization. The curves became cleaner, almost algorithmic. What began as rough bursts evolved into perfect periodicity. The comets were not merely responding, they were adapting. At Princeton's Department of Astrophysical Sciences, a young postdoc named Ravi Mehta plotted the acceleration data across 43 observation cycles. His discovery went unnoticed by mainstream outlets but circulated quickly among researchers. The frequency of the acceleration matched a precise fraction of the Sun's rotation rate, 1/24th of its sidereal period. This isn't random timing, he wrote in his unpublished notes. It's synchronization to the star itself. He never got to publish the paper. By mid-December, his university email was deactivated for policy review. But Mehta's graphs lived on. They showed that both Atlas objects seemed to listen to the Sun, accelerating and dimming in harmony with its rotation, as though the star's magnetic flux dictated their rhythm. That realization terrified people more than any talk of alien craft. Because if the comets were reacting to the Sun, not Earth, then their choreography was part of something far larger. And so the question shifted from what are they to what are they doing? By the week's end, the comets had reached near-perfect luminosity synchrony, their combined light forming a faint golden shimmer visible to the naked eye before dawn in the northern hemisphere. Thousands of amateur astronomers posted images online. The caption most often repeated under them was not scientific at all, but almost instinctive. They're moving together. And across observatories, under the dim hum of machines and late-night monitors, scientists stopped talking about comets. They began to talk, carefully and quietly, about behavior. The deeper scientists dug, the stranger the matter itself became. By December 10, 2025, laboratories around the world, Caltech, the Max Planck Institute for Solar System Research, the University of Tokyo, and Harvard's Department of Earth and Planetary Sciences were all running spectroscopic decompositions of light captured from the twin Atlas objects. The goal was simple: find something ordinary to cling to. But the data only widened the chasm between what telescopes saw and what physics allowed. The spectroscopic line structure of both comets was sharp, not diffuse. That alone was unprecedented. Natural cometary surfaces scatter light unevenly due to regolith irregularities. Their absorption bands are broad, blending into noisy baselines. But in the Atlas samples, the lines were narrow and perfectly separated, like laboratory measurements taken from refined metallic alloys. At first, scientists attributed this to instrumental artifacts. Perhaps the detectors were oversaturated. Then ESO's VLT in Chile, NASA's infrared telescope facility, and the Subaru telescope in Hawaii compared raw calibration files. All instruments agreed to within 0.03 nanometers. The measurements were real. The elemental ratios stunned everyone. Where carbon signatures should have dominated, there were traces of nickel, cobalt, molybdenum, and trace tungsten. A combination consistent not with cosmic debris, but with engineered superalloys designed for high-temperature stability. "It's not what we expect to find drifting between the stars," said Dr. Adam Müller, a materials physicist at the German Aerospace Center, DLR. "It's what we use to build rocket engines." Her words made headlines. And then her lab's report vanished from the DLR's online archive less than 12 hours later. A week later, a sealed memo circulated through the European Space Research and Technology Center, ESTEC. Its summary, later leaked to Science Nordic, read simply: preliminary compositional models inconsistent with silicate, carbonaceous, or icy matrices. Reflective features resemble microfaceted crystalline composites. Hypothesis: non-stochastic surface architecture. In plain terms, the surfaces weren't random, they were structured. Radar mapping from Goldstone supported that claim. The reflections came back not as diffuse echoes, but as discrete spikes, coherent scattering. The time intervals between peaks were regular, implying uniform geometry across the object's surface. "It looks tiled," said Dr. Robert Kwan of the Royal Astronomical Society, "like thousands of hexagonal panels reflecting sunlight at slightly offset angles." But no natural process could explain a tiled, nickel-rich object stable against solar heating. To keep from melting near perihelion, the material would need to have a melting point above 1500 Kelvin, yet emit almost no infrared heat. The only way to achieve that was through active thermal management, cooling, reflection, or something else. When a journalist from Nature asked NASA's Planetary Materials Division for comment, the reply was sterile. No confirmation exists regarding claims of metallic composition. Current models remain consistent with silicate bodies displaying anomalous reflectance. But internal NASA documents told another story. Among the files later exposed in the Atlas document dump leak, one internal slide deck included a chart comparing the comet's reflectance curve to various terrestrial materials. The best match was labeled Nifetico, engineered, not geologic. Across the Atlantic, the ESA's Solar Physics Division noted something else: a faint, repeating emission line at 1420 Fordor 575 MHz, precisely matching the neutral hydrogen frequency often monitored by SETI. Though officially dismissed as background interference, the signal coincided with polarization shifts observed in both comets. "Every time the surfaces flicker," wrote Dr. Lena Moretti in her private log, "we detect a subtle radio pulse. It's as though the light and radio channels are harmonized." No agency confirmed the phenomenon publicly, but the chatter grew impossible to contain. Astronomers began whispering the unthinkable: what if we're not studying a comet at all? At an emergency workshop hosted by the International Astronomical Union, IAU, physicists attempted to stabilize the narrative. "Nickel and cobalt aren't proof of anything exotic," insisted Dr. Peter Haldane, a veteran astrophysicist from Cambridge. "Space is full of surprises. Nature doesn't owe us simplicity." His voice, calm but tired, echoed through the auditorium. Then, from the back row, a younger researcher from Finland stood up and quietly asked, "If it's natural, why is it behaving like a machine?" The question silenced the room. Later that evening, another leak surfaced, a joint NASA-ESA technical assessment drafted by an unnamed multi-domain analysis group. It analyzed the chemical ratios, the synchronized acceleration, and the photometric modulation. The last line of the document, redacted everywhere but one screenshot, read, "If non-natural origin is excluded, we must consider adaptive material systems beyond current Earth technology." It wasn't proof, but it was an admission that proof might not be necessary. Meanwhile, the comets continued to change. On December 14th, the Golden One, C2025K1, grew brighter again, then steadied. 3I Atlas, the interstellar traveler, mirrored the shift 6 hours later. Observatories recorded subtle hue fluctuations across both objects, with spectral peaks sliding up and down in unison, as if the two bodies were scanning the sun's spectrum, reading it like code. The rhythm had evolved. What began as random flicker was now structured. Modulation, clean, quantized, almost musical. "They're harmonizing," wrote Dr. Avi Loeb in a private email later published by Scientific Frontiers. "Two bodies, one voice, and we still pretend they're rocks." By mid-December, no one could deny the data. Two luminous objects, composed of engineered metals, cooling under solar heat, moving with precision, exchanging synchronized signals, were behaving not as debris but as devices. Yet, despite everything, the official record remained unchanged. To the public, 3I Atlas and C2025K1 were still comets. Inside observatories, the word comet had become a euphemism, a polite way of saying we have no idea what we're looking at. By December 18, 2025, the orbits of both Atlas objects had been charted with enough precision to make or break 1,000 theories. And what the orbital models revealed left even the most conservative astronomers staring at their monitors in silence. When plotted on a heliocentric frame, 3I Atlas and C2025K1 Atlas didn't follow the chaotic, slightly precessing paths of natural bodies. Their ellipses were mathematically elegant, mirror images of each other, symmetrical around the ecliptic. More astonishingly, the objects were maintaining a constant angular separation of 0.52 to 3 degrees, adjusting minutely with solar rotation as though holding formation. "Nature doesn't do symmetry with intent," said Dr. Pierre Lavigne of the European Space Agency. "And this looks intentional in every sense except that we can't admit it is." The International Astronomical Union, IAU, which had convened an emergency session in Geneva, found itself paralyzed. The official draft statement proposed by the IAU's Near-Earth Object Task Force used phrases like active orbital modulation and controlled trajectory preservation, language that sent shockwaves through the scientific community. Before the statement could be finalized, it was replaced with a sanitized version reading, "Observed orbital adjustments remain under study. Gravitational perturbations and nonlinear solar pressure effects cannot yet be ruled out." But privately, nobody believed that anymore. An independent statistical analysis by the Harvard-Smithsonian Center for Astrophysics compared both ATLAS trajectories against the distribution of known long-period comets. The odds that two distinct objects, one interstellar, one native, would share such matched inclination, eccentricity, and phase timing was 0.002%. When corrected for discovery date, brightening factor, and synchronized rotational period, the combined probability of coincidence fell below 10 to 7. In simpler terms, the universe would have to roll the dice 100 million times to produce this alignment once. Meanwhile, in Tokyo, the JAXA Institute of Space and Astronautical Science published a brief technical bulletin quietly noting that 3I ATLAS had executed a discrete course correction. Between December 12th and 15th, a lateral delta V of roughly 2.7 meters per second. The report was quickly withdrawn, but copies persisted on mirrored servers. "It's not gravity," commented Dr. Hiro Tanaka, its principal author, when reached through encrypted email. "It's guidance. Guidance. Another forbidden word." NASA's Near-Earth Object Coordination Center attempted to suppress further speculation by locking the online ephemerides of both comets, replacing live data with a static projection, but independent astronomers were already calculating their own predictions using Gaia's last open dataset, and what they found was impossible to hide. The two ATLAS bodies were converging, not toward Earth, but toward a mutual rendezvous point just outside the orbit of Venus, a region of low solar turbulence often used by spacecraft to minimize drag. Their predicted paths would bring them within 30,000 kilometers of each other by late January. To engineers, that sounded less like coincidence and more like a planned intercept. At the Royal Astronomical Society's December colloquium, Dr. Carla Dufresne presented a session titled "Non-Randomized Dynamics in the Atlas Pair." Her team had reconstructed the trajectories using radar cross-section data and found that both objects subtly corrected for solar wind fluctuations in ways identical to low-thrust solar sail vehicles. "The ratio between acceleration and photon flux is textbook," she said. "If this is natural, it's the first example of nature accidentally building a spacecraft." Her presentation was cut short when a NASA liaison in attendance interrupted, citing sensitive implications. Soon after, a flurry of cryptic updates began appearing across public satellite registries. ESA's Gaia, NASA's SOHO, and China's Chang'e Deep Space Network all logged temporary data outages when the Atlas pair passed within line of sight. In each case, the instruments returned online minutes later, without explanation. Outside academia, the story broke into mainstream headlines. "Two golden comets moving in formation. What are we really seeing?" BBC Horizon. Scientists detect patterned course corrections in twin visitors. Le Monde. A cosmic ballet. Or a signal. The New York Times. For a moment, the world looked up. Then, on December 20th, an internal SETI memo surfaced. It compared the orbital plane of the Atlas pair with the sky coordinates of the famous 1977 WOW signal, the mysterious narrowband radio burst that had confounded astronomers for nearly half a century. The angular deviation was 0.6%, within observational error. SETI director Dr. Teresa Aguilar refused to draw conclusions, but her words lingered. "If the alignment is deliberate, it's a gesture, a return to the coordinates of humanity's first unanswered call." It was too poetic to be coincidence, too neat to dismiss. Even the most skeptical physicists began whispering what they'd once mocked. Perhaps these trajectories were not random relics of celestial dynamics, but lines of intent, geometry as communication. At Harvard, Avi Loeb went public again. publishing an essay titled The Geometry of Intention. He wrote, "We are witnessing a choreography too consistent to be accidental. Whether it's cosmic coincidence or deliberate design, the universe is pointing at itself and asking if we are paying attention." Within 24 hours, the essay vanished from Scientific American's website, but cached versions spread across forums, accompanied by an image that would haunt astronomers for years. Two perfect golden arcs, meeting near Venus's orbit like halves of a circle, traced in the faint glow of reflected sunlight. For the first time in recorded history, humankind had numerical, geometric, and physical evidence suggesting that something in space was navigating with purpose. No message had been received, no alien craft had appeared. There were only two objects, silent, brilliant, and precise. And every night, as they curved together through the black, they seemed to whisper through motion alone, "Watch closely." The convergence began quietly. In the early hours of January 24, 2026, deep space radar stations in Spain, California, and Canberra all picked up the same pattern. Faint, rhythmic pulses at 1420, 4258 MHz, the hydrogen line, the universal constant used by astronomers to mark the presence of life-bearing chemistry. The signals weren't continuous. They came as three discrete bursts, each 12 hours apart, perfectly aligned with the synchronized brightness cycles of 3I Atlas and C2025 K1 Atlas. To the untrained ear, it was static. To the spectral analyzers, it was coherence, structured, repeatable, and mathematically deliberate. The last time humanity heard something like that was in 1977, the WOW signal. And the direction, once plotted against the new orbital paths, matched within 0.6 degrees. When the data reached the SETI Institute, Director Teresa Aguilar issued an internal statement: "We are not confirming a repeat event. However, we note the recurrence of hydrogen line coherence synchronized with orbital mechanics previously observed only in artificial radio sources." The memo was supposed to remain private. It leaked within hours. By sunrise, social media lit up with hashtags. Dagse Atlas response, Maxhak second wow. They answered. Governments moved fast. NASA issued a curt press release claiming interference from solar activity. The European Space Agency attributed the spikes to resonance harmonics within receiver arrays. The Pentagon classified all remaining deep space telemetry from both comets under the umbrella of national security. But the world was already watching. Civilian radio telescopes, small university dishes in Italy, amateur SETI networks in Australia began capturing the same pulses. The pattern was too consistent to dismiss. Each signal echoed precisely 12 hours apart, each coinciding with the alternating brightening of one Atlas object and the dimming of the other. They weren't just reflecting sunlight anymore, they were communicating through it. At Harvard, Avi Loeb gave an unsanctioned press briefing streamed on social media. Standing before a wall of orbital plots, he pointed at the intersection of the two paths just beyond Venus. "If this is coincidence, then coincidence has a sense of humor," he said. "If it's communication, then geometry is the language." His stream was taken down within an hour. 2 days later, on January 27th, the Atlas pair reached their predicted convergence point. 30,000 kilometers apart, gliding through the inner solar system in perfect synchrony. Their relative velocity dropped almost to zero. For 27 minutes, the light curves merged into a single pulse, golden white, steady, unblinking. Then the signal stopped. Every telescope pointed their way. Hubble, ALMA, Subaru, even the James Webb Space Telescope, which was redirected for the first time in its mission's history, all recorded the same thing: silence. No emission lines, no radio echo, no motion. Just two still objects, reflecting sunlight with surgical precision. On Earth, scientists scrambled to interpret the quiet. Some argued the event was over, a flare, an alignment artifact, an elaborate cosmic trick. Others saw meaning in the geometry itself, the twin ellipses that, when plotted, formed the shape of an incomplete circle. as though the universe had drawn a symbol, not a message. The International Asteroid Warning Network, whose sensors had first tracked the anomalies, released a final statement on February 3rd. After a review of all available data, the dual objects 3I Atlas and C2025K1 Atlas have resumed non-anomalous trajectories. No further non-gravitational acceleration detected. In the margins of that report, buried in the metadata, was one unpublicized note. Minor reflectivity oscillations persist. Pattern appears deliberate but non-threatening. Then came the last recorded observation. On February 5, just before dawn, a private observatory in Namibia captured a sequence of images showing both comets beginning to drift outward again, opposite directions, divergent paths, fading into the black. Their synchronized brightness dissolved, replaced by randomness. Whatever they had done, whatever they had shown, it was over. And yet, one question lingered among the community, echoing in every late-night seminar, every off-record conversation, every silence after a deleted email. Were the Atlas objects simply natural coincidences magnified by our collective imagination, or had something used the cold precision of orbital mechanics to say hello? The answer never came. But every year since, when the Earth crosses the plane of their old orbits, radio astronomers still tune their receivers to 1420 MHz. They listen not for a message, but for motion, for that same faint golden shimmer against the void. And sometimes, when solar winds are calm and interference is low, they swear they can still hear the faintest rhythm. 12 hours on, 12 hours off. Like a pulse too vast to measure, beating quietly beneath the stars. Because maybe the universe never stopped speaking. Maybe we simply learned to recognize the voice.